My name is Anisur Rahman. I'm coming from Asian Disaster Preparedness Centre. Um, I have not given the overview of my organization, but I'll tell a little bit. It is an organization based in Thailand, and it is working in the last 25 years in disaster preparedness and disaster management. And over last 2.5 years, we are trying to apply the satellite and GIS data, especially for hazard and risk assessment. So earlier we had a lot of programs and in the region for different trainings, and we are working with national organizations in Southeast and South Asia, and up to now Africa we are also working. So this presentation will be focused on earthquake risk assessment that we have recently completed in Bangladesh. So I will be focusing on earthquake only in this part. So over the last 3 years, we have completed 2 major projects in Bangladesh that includes seismic hazard and risk assessment in 3 major Bangladesh, that is Dhaka, Chittagong, and Sylhet. And we have recently completed 3 another similar kind of projects that is in Rangamati, Bandarban, and Khagrachuri, which is a part of EC mode. That if you have followed the first presentation in the morning, that working area of EC mode. So the black shaded area is Bangladesh is very small part. So the right hand side, these 3 small municipalities are within that part. So that is actually the hilly areas where we have conducted this seismic hazard and loss estimation. So what we have tried to do this in these 6 projects, in 6 cities projects. So we have applied satellite images to map the infrastructure, buildings, and all other attributes. And we have used Hazus. It's a software that is a multi-hazard risk assessment software that we can use for assessing earthquake, flood, and cyclone. So that we have utilized here for assessing these things. So what does this Hazus can do, actually? That's just a brief on it. So it estimates the physical damage to the building and the contents. It estimates the physical damage to the lifeline infrastructure like bridges, pipeline, and all other things. And it assesses how the population might be affected, because it actually gives the figures and give an estimation that what is going to happen, how many people are going to be affected, how many people are going to be injured or even killed. And it tries to give an idea based on what we can take any sort of preparedness for these 3 kind of disasters. Actually, this is how it works. Actually, this if you can follow here, that we have 3 sort of things in this earth. So this is where we are normally. We can we see people we live here with the infrastructures, and we have the subsoil informations in all spaces, and this is actually the preparedness things, and how we can prepare ourselves. In consideration of these 2 things, we can get these informations, and then how we prepare. So Hazus can be used for these 3 things. So we have utilized this Hazus for this earthquake preparedness in Bangladesh. So this is how it works, this is the basic concept how we have applied these things. First is the building stocks that we have considered, then geological data, and then seismic hazard. So combination of these 3, so we have assessed these earthquake vulnerabilities. So first is this building stock and lifeline system. So this is very important, which we have seen in the previous 2 presentations. So this data is one of the image of the cities. So this is how clearly it shows. We use the quick bar. You see this from this map, how clearly we can see this. And then we have first geo-reference these things with more accurate GPS systems. And then also field verifications, because we got this road width and other things from the image, so we verified these things in the field actually, whether this was correct or not. And then we have developed this. This is the paper map, the ultimate product that came, and how accurate this we have also tried to identify. So this is the map. Actually, you can see we are collecting the attribute informations. This is actually the second time revision of the map. You can see, and we have also you can see the corner of the building, and if you see the shape of the building, it is almost the correct thing. So we have tried to collect the information like this, and we have tried to verify and also. So this is how we develop the base map, and ultimately it's give very clear kind of pictures. Like in Dhaka, we can also say that how many number of buildings are there. In Chittagong, we can say exactly what is the number of buildings, and we have a lot of attribute information inside. So I'm not showing you all these things in the short time. So this, So this is the detailed kind of maps we developed for these six cities, which were in our project area. So, and also this is the lifeline information what we have also incorporated in the base map, because the lifeline information, underground things, basically these are not visible. So we collected this information from our line departments like water supply department and gas supply department. So we have also incorporated these things into digital format. Actually, these are the inputs that are required to get this to have this risk assessment. So first we had to develop a very detailed kind of base map for this study. So and we went into the details. This is actually the unit of a boundary which Hazuz actually take into account and go for this risk assessment results. So if you see, so this is actually the total city, and then this is one unit of administrative unit we call ward, and from this ward we have again divided into small segments. So this is based on actually the physical boundaries, main roads, and within this area we have got the picture of how many people are going to be killed, how many buildings are going to be collapsed, and how many buildings are going to be partially collapsed. So we can get the result based on these small units. So we have got this kind of result from this study. So the second thing is geological data. What we have, second thing is the vulnerability. So first I have told you that how we have developed the base map. Second is that the attribute we have collected to assess the vulnerability. So since this was earthquake, so we had to consider the buildings and the infrastructures. So we had to go into the very detailed kind of survey for buildings, different kind of buildings. We had several levels, so level 0, 1, 2, 3. So these levels actually varies from the in-depthness of the survey. So those who are structural engineers, so they can understand. So these are very detailed kind of survey. You can see this is the level 1 and level 2, where we just see the visual things and these things. And level 3 we use different equipments to go into the detail. We use the spero scanner, Smith hammer. We use the vibration shaker also, micro trimmer to have the idea about the shaking of the motion of the buildings. This is some of the equipments, and for masonry building we also we tested the mortar quality, how it works. So after all this, we got this fragility curve. So actually this is to be used, is how vulnerable this type of buildings actually. So this is one of the inputs, basic inputs for the Hazuz to be used actually. And the third stage, the geological data. So far I have shown what we have collected in the over surface. So now we had to also collect the geological data which is below surface. So this is the soil quality, how it is, whether this is rock formation or this is actually loose soil, or this is sometimes this in the hilly areas, these are coming from the hills over the years. So we also tested, and then also the geophysical surveys we did also using micro tremor. So this is actually giving the underground information, how it is, whether it is soft or not, how it will behave during any earthquake. So the final step, actually, combination of these three things, three basic things, we then run this software, Jesus, to model this assessment. And actually there is one, because this Jesus actually developed for USA. So it is developed fully in their system. Because if we try to use this, we have to change many things to coordinates, and we have to run it in their region and these things. So some of these parameters we try to adjust with our region, and after that we have tried to model this thing. So in combination of these things, actually we have got the result of this, what is going to happen if there is any earthquake. And this seismic hazard, actually the final thing that we got. So this is the final part what I am trying to show you, that what is the result we obtained from this using of satellite image, then GIS, then also the what they call this attribute information, collecting from all aspects of things. So what is the result, and what can be used basically for this disaster management, which is very difficult to get instantly soon after any disaster. What is the first presenter was, he was just mentioning that it is very difficult even to assess what sort of vulnerability or what sort of damage was there in the Pakistan flood. So this is how it is. This is actually, in that project we instantly also identified the sources of earthquake in Bangladesh. Active faults we also studied. I did not present that. That is different one. But we also studied what might be the active faults from the earthquake may generate. So these are the 5 we got, and we have actually generated the earthquake from these sources to have the scenarios actually. So we considered the medium type, very extensive one, and moderate one. So three type of scenarios we tried to develop for all these 6 cities. So I'll try to show some of these things. So this is the PGA map, peak ground acceleration map. So how it will be. This is for Dhaka's case, and this is how it is how the damage may be. So you can see that it gives a clear picture that which areas are most vulnerable in terms of this map is in terms of concrete buildings. So how many buildings are going to be collapsed, we can easily identify. Oh, this is the moderate one. This is the moderate one. And this is the detail we can get from here. We have actually get the very detailed kind of things. So for case 1 in Dhaka, the expected number of a structure type. The very detailed kind of things you can see here. This case 1 for Dhaka, how many buildings will may collapse, and very detailed kind of things we can get actually. So this is the casualties, how many people may die or how many people may injured or something like that, and how many people may be inside the buildings even after collapse of the building. So this the casualties during daytime, how many people will be affected if there is an earthquake, if night time, how many. Both scenarios are here. So this is the 3D, how we can see the visibility of risk. We can even see which buildings are in risk position. If we just make the map in 3D, so we can see also this kind of thing. So the final thing is what is the use of these things actually. So first is the identification of the vulnerability. Then next is the level of readiness, whether we are ready for to face these kind of disasters, and then estimate potential loss, how many people, because these results are also giving how many debris will be generated. So if you follow the news from this Haiti earthquake, so they have estimated that the buildings they have collapsed. So to remove these debris, it will take 6 years to remove these debris in Haiti. So already we can tell from Dhaka's case, or for these cities' cases, how many trucks it will take to remove the debris. So this sort of information that we can get from this assessment may be useful for these disaster management organizations, and also for this UN agencies to come forward, because this earthquake type of disaster is not affect a nation only, but it also affect regionally and also internationally. So everybody can get the information and get an idea that how to respond this kind of disasters if there are any. So this is my presentation.